Again, I'm just in shock how big of the water bottle we have. Alrighty, that's the time. Timer is on. Let's get started. So, hello everyone. My name is Dmitry. Hello, hello. Thank you for joining. As you can see, we're going to talk about web testing today. But first and foremost, similar to my previous talk, I always like to make sure the goals are very clear, that this talk is not very, individual tool-oriented discussion where I'm teaching you how to use a particular tool. Instead, it will be more conceptual and just making sure that we have a kind of a design approach when it comes to test infrastructure. So this is why the first goal that we're trying to establish is to choose the right context that you should be implementing in your test infrastructure when it comes to the web testing. Then important thing we're going to discuss is how to choose the right level of testing. And the last would be focusing on end-to-end tests and what kind of approach you might want to take along with your team. And it will be very team specific and the use case specific. So that's that. Let's go into more details. So when it comes to testing in general, the common question is how do we even test? And I hope everyone's seen this figure in the past, basically the so-called test pyramid, where in the bottom layer and the bottom level you have ideally the highest number of unit tests, which implies that you're supposed to have the biggest number of those. They follow three simple principles of being the cheapest in terms of the cost of maintenance and writing them. They are the fastest, so because they're fast, ideally developers actually going to run them. And the last, they're going to be only giving you very low level of fidelity. In other words, the confidence level that you get from just running the unit tests alone is fairly small. So this is why we have to go up the pyramid a bit and have integration tests that instead of comparing to the unit tests, which test only individual unit of work, integration tests, they exercise the integration part, meaning they try to test how multiple units of work together, multiple components, multiple services, so they might even apply running an actual application if necessary, but that's debatable. And the last part is having end-to-end tests. But the reason why it's on the very top is because we're supposed to have the fewest number of those. Unfortunately, that's not always true. And the main reason why we even say unfortunate is because they are the costliest to run, to maintain. They are the slowest, which it usually gives the bad rap to the end-to-end test frameworks. And the coolest part, though, is that they actually give you the highest level of fidelity, the highest level of confidence in the overall quality of the product. And the main reason is that ideally end-to-end tests should only be written for real user scenarios. So they're very user-centric. Unfortunately, in many organizations, it's the reverse situation where people emphasize end-to-end tests and instead they write them for every single edge case out there. And this is why in the real life, and in terms of the web testing, we unfortunately have different types of test pyramid. The first one is so-called ice cream cone. Another one is an hourglass. And the last one is a cupcake. It's fairly sweet kind of pyramids here, but unfortunately they're not so sweet to work with. And if I were to look at the ice cream cone, the one I see the most at an example drawn by Team Cochran and his article that I've linked in this slide, where basically you have the unfortunate situation of have very few number of unit tests, more service or not, how I call it, integration tests, and the highest number of unit tests, UI tests, sorry. That being said, these companies also often have a lot of manual testing involved. So every time developer implements a feature, some manual team has to run the regression suite. And sometimes it's done by hand. So this is not very scalable system. And even without manual testing, often I see that so many UI tests are in place because they are written for every single edge case out there. The hourglass is slightly different, a little bit better, but still has its issues. The hourglass looks something like this, where you still have a very large number of UI tests on the top, but you have a lot of unit tests. This is often the result of being very, not mature yet team. In other words, they still run and create a lot of UI tests for every single edge case, but they've tried to implement test-driven development in a team that they're working in. This is why they have so many unit tests. But they bypass the integration test and still stick to the old practice of writing UI end-to-end tests. So this is where the hourglass comes from. And the last one, the cupcake, this one always confuses me, but honestly what it basically shows here, it's still dysfunctional in the sense that you have a few number of unit tests, a lot of more complex integration and UI tests. And primarily the issue in this kind of cupcake pattern is that there is a lot of duplication between the levels. So as a result, they have lots of UI tests and even manual tests on the top. So with this kind of a bittersweet pyramids way, the whole point again of this talk would be to highlight that when it even comes to web testing, to change this, to go away from this real life test pyramids towards the one I've shown at the very beginning with the proper number of unit tests, integration tests, and UI tests. That's what I'll try to highlight today, that you don't have to write as much Selenium. Unfortunately, again, the company I'm working with, they are one of the primary users of Selenium WebDriver in the world. And it always pains me because I identify the problem that many people who join companies, especially junior engineers, or even those who like higher level ones, they're not taught necessarily when to write tests. They sometimes taught how to write tests, how to like write unit tests, integration, and UI tests, but they're not explained when to write what. As a result, that scenario of writing UI tests for every single edge case comes into play, and this is how we end up with this reverse pyramid. So, for today, I have to kind of highlight some sort of a demo project we'll be using to test throughout the presentation. So with that, and saying something that we're going to test, basically, it's something that every other person who talks about UI automation has to refer to. It's this todomvc.com, which basically has this simple to-do app in every single UI framework out there of your choosing. For example, you can choose like Angular and see the same application. I really don't like how bad of the contracts they have. Basically, it's basically a to-do app. You can call an app like talk at GeeCON. You know, it creates a to-do item. You can complete it, and then go to after party. This one is important, so this one has to be here. So you can close it, create to-do items. So basically, as simple as it gets. But this website is pretty cool because you can see different POCs for different languages. But ultimately, this is what we would have tested, and that's what we're going to go through in today's presentation to give you some context. But back to the testing itself. The first case we will be considering, let's say, our backend. So we have an app, but our backend, like let's say written like in the Spring Boot or primarily uses Java on the backend. And what I often see people do is that they also decide to test in Java and write a WebDriver test in Java. In the past couple of years, I've started moving away from this approach. And this is why I say there is a problem with this approach of just writing Java on the backend because your backend is written in Java. And the reason why I say that is because in terms of the web, the context really matters. And there are three main points I make. The first is that, especially in North America, we're moving towards this so-called hybrid model, which I'll talk about in a second. The domain-driven design is a very cool concept to implement, hence I usually push for the writing tests not on the back end. And trying to keep them user-centric, even if when it comes to unit tests for web. And I'll talk about that in a minute. So, when it comes to the hybrid model has been this new fab, and especially, as I said, in North America and in the West Coast in particular, where they basically try to make everyone a software engineer. They don't have this separation between developers and testers anymore, which the previous test pyramids have showed. One of the issues I've encountered sometimes when departments are strictly separated. Basically, you can almost say like there is a huge fence between developer department and the tester department. So as a result, when developer completes their work, they take that piece of work, they throw it over the fence, like if it was like a soccer ball or something. So they throw it over the fence to the testing team. Testing team picks it up, starts testing. And they often don't communicate to the developers ahead of time, and as a result, they work with it as if it was a black box testing. And when it comes to black box testing, people often end up doing just user testing, which in cases of web applications would be UI tests. This is how many manual testing teams end up just writing the end-to-end Selenium WebDriver tests. So basically, that's one of the problems people have been trying to solve by moving towards this hybrid model. I don't necessarily advocate for that, but that's basically been the case of trying to solve this problem of just throwing the ball over the fence to another team that's going to test it, and try to have everyone in the team responsible for the quality of the product. This is why everyone is a software engineer that follows the regular software principles, but also has a testing expertise. And the testing expertise is one of the most essential practices that the software engineers have to implement and have in their head. The hybrid models have been failing in some companies, and primarily because when this merge happens between the two roles, people emphasize, let's teach our testers how to code, but more often than not, the main problem is in developers who have no testing expertise and think it's going to be taken for granted. So the testing expertise is as important as the developer practices that often come from the developers when this merge happens. Basically, it's the combination of two and trying to connect and have the responsibility on a team level. The domain-driven design, it's a fairly simple practice as well. At least in a simple term, if I were to highlight two main principles, that there is a ubiquitous language that we all try to follow. In other words, when you have different stakeholders in the team, whether it's testers, developers, domain experts, project managers, project owners, whatever you're going to call them, you try to make sure that you all name things in the same language and that the context really matters. It all comes down to how you discuss certain aspects during the meetings, how you write documentation, or how you even write your code. To give you an example, that communication between developers and testers. Let's say we are working on the authentication system of some sort, and the developers in their production code, they have a customer.java class. As a tester, I'm trying to write a test for that customer class, and I call it, for example, I don't know, test account.java. Now you have this separation of the language. I'm calling it an account, test account. On the testing side, developer calls it a customer. It might not sound like a complicated issue, but when the new person comes in, you have to explain to them that, oh yeah, so we have this customer object, production object. In the testing scenarios, we call it an account. Again, it might sound trivial, but as we scale up, those language differences matter drastically. So we try to have this ubiquitous language and the context established within the team. And this is again where separating the backend testing from the UI testing that most production engineers these days who write web apps work on is not something we want to go for. And again, trying to keep it user-centric, that because the customer ultimately interacts with the UI. If you're a UI team, that's why when I say web testing here, I'm not talking about the teams that primarily focus on the API, because it will be a completely different case, because you will be using something like REST Assure for REST testing. Here, we're really focusing on going away from the teams that primarily focus on UI testing and writing the Selenium WebDriver tests. So keeping it user-centric is really highlighted when you even write your unit and integration tests on the client side, not just on the backend. And again, if you're not convinced, then that's totally fine. It took me a while to change my views on that regard. When it comes to the web testing, if you say the web itself, really you have to highlight the power of JavaScript. Hence, JavaScript has been so popular these days. One of the cool things, of course, is that they have lots of assertion libraries, which is so important for testing. One of the most important things when you make any sort of shift in terms of testing practices or production practices of any kind is how easy it is for your team to make a transition, if you decide to do so. So because of the assertion libraries that are provided in JavaScript, the transition is not that complex, and I'll show it to you in a second. They have lots of process libraries for different methodologies, and the enterprise library support by different enterprise companies is quite extensive as well. To give you an example of assertion library, there are a ton of them like Chai, Jasmine. Process libraries, if you want to go for BDD, there is obviously Cucumber available for the JavaScript. And for the enterprise, things like Apply tools, that's very massive for support for visual testing, if you're really trying to do that. JavaScript has really been, we all know it's quite popular. So when it comes to the testing, we have to acknowledge that importance for the development world. So if I were to speak, again, if I were to say speaking language of the web, we have to say that it's JavaScript and Node.js. People can disagree, of course. Some people might even say, no, WebAssembly is the way. Let's admit, I mean, for now at least, let's call it a JavaScript. When it comes to Node.js, because of some of the benefits of Node.js, like it's being isomorphic. In other words, you can write it for client side and the backend. The fact that it's very flexible and the number of customizations you can actually have, the imported packages you can have with things like npm manager. And now I believe it's even like GitHub offers some package managers. That being said, with just these couple of highlights, the Node.js is quite powerful, whether it's for production code or for the testing alone, and I'll show it to you in a second. So with that kind of a theory and kind of introduction in mind, going back to the test pyramid, to the web test pyramid, it's still the same test pyramid. And as I've said before, one of the most important ideas that in the goals that we've established up front is that we will try to write more web tests, but not with the Selenium WebDriver, meaning not with like a end-to-end approach, because it is still possible to do so. When it comes to unit tests, they still follow the same three principles of low cost, high speed, and low fidelity. And if you look at the unit tests for the web context, you have to consider things like, first let's consider the function we want to test. And let's say we wanted to write a test in Jasmine, one of the assertion libraries I've mentioned. As I've said before, we're not trying to learn how to write a test in a particular framework that I'll be highlighting today. It's to show that all those test frameworks I will be describing here, they all follow the same three principles as any test would. You arrange the state, the conditions, you act on them, and you assert them. So if your team uses whatever language or whatever testing framework, you can easily shift to another, like the front end if you wanted to, and it will be the same pattern, almost the same syntax. So for example, we have a simple function in production for this to-do application, the MVC application I showed you before. This simple function basically takes an input, converts it into a certain JSON format, and returns it for further processing. Doesn't matter what it actually does. It's very simple. What I'm trying to show is just a simple operation that takes an input, converts to JSON, returns it. Doesn't get simpler than that. But if I wanted to write a test, again, if you're writing the test in Java today, or in C# or whatever language you do, it's the same in Jasmine. You create a test suite, you name it a certain way. You create a test case, you name it a certain way, the way you would, because semantics really matter. This idea of ubiquitous language that I've showed before really is highlighted here as well. Then you arrange your scenario, you basically arrange the data you want to have, you act on that, you create an item, and then you want to do some assertions. So the same three principles of arranging, acting, and asserting. And you would write it the same way you would do in Java, if we compare it to Java, top to bottom. So there is no complication with the asynchrony that you might have encountered in the past when it comes to JavaScript. So if you wanted to shift to this approach, it would be fairly simple. And again, the main use case for this, even shifting to the client side, is if your team, your production team, is primarily writing JavaScript for the client side, and you're trying to start writing tests for the client side, for the UI, starting from the bottom basically of the pyramid on the unit test level. So the Jasmine really helps with that quite a bit. When it comes to the integration tests, obviously there is an awesome framework called Jest. It's an open source framework. Facebook works on that a lot. One of the cool things that I like about Jest, apart from it being they do a lot of cool mocking if you wanted to. But one of the nice things, especially in terms of integration tests, and in particular around legacy systems, is their support for snapshot testing. So in this example, we have that MVC to-do app that's built with React. React components as a whole, think of them like as classes in object-oriented programming. If you look at the component-driven development, it has similarities in that regard. But ultimately what matters is that it looks like that, this component. It creates a virtual DOM or creates basically a button for you, which goes down to the simplest DOM. And it also has a style here as well, so it has some styling involved. But when this component is rendered in the UI, it generates the DOM ultimately. And the snapshot testing, what it does, if I want to write a test, so I name it a test. Simplest thing I do, I basically run a renderer. There's a nice helper class provided by Jest. It helps me to render the component individually, which is great because I don't want to render the entire application. So again, it keeps the testing fairly fast. And that's the only way to get anyone to run your tests and use them on a regular basis. And then I basically convert it to JSON and compare the snapshots. So this code is going to be the same for majority of components, at least for the sanity tests. And what it ultimately does, it generates this snapshot, or basically it generates the DOM for this component, saves it as a jest file, and makes sure it doesn't regress if someone makes a change to this component. This gets fairly complex to maintain in like very actively worked on products. But if you have a legacy system, you have a legacy product, or a product that should never change, you want to have a quick regression suite. Because as we all know, Selenium WebDriver more often than not end up being the regression suite. So if you're looking for a regression suite to be faster and simpler, snapshot testing might be a good answer for that. But if you do it on an actively developed product, it might be a pain to keep regenerating these snapshots over and over again. And if you get people failing this test all the time or keep updating them, they're going to start hating the product fairly quickly and the testing tool as well. So you want to keep it kind of if you're going to start with that, start with the legacy products. But so far, those first two levels that I highlighted, the unit tests and the integration tests, they all have a single focus, and that focus is on developers. And it's very important to basically have those tests that allow you to test for customers, for real users, for the UI, while keeping them fast and easy to run and easy to write. Because there are only two main ways to drive adoption of any kind. The first way, the adoption of the test framework in this scenario, or adoption of the product or a service. The first way would be through threats and fear. You know, if you are a manager, you want to scare your team to run the test, otherwise they'll fire it. Or you know, or like with taxes, you threaten people with jail if they don't pay taxes. The second way, better way to drive the adoption of any kind, is to make it easy to use. So with the Jasmine or Jest, the whole idea is that it's easy to write those tests. It's easy to run them. It's fast to run them. If you make it nice and easy for people to implement, they'll actually start using it, and that's the only proper way to drive adoption, even when it comes to just the test infrastructure. But you know, developers are not the only people we're working with, and not the only target audience that we have as test developers. So it's good for some, in the sense that having these first two levels of pyramid. But for end-to-end tests, it's not as simple as that. For the end-to-end tests, that again have these three main principles that kind of constrain us, but also give us the focus that they still are the costliest, they're the slowest, but the highest confidence level. Here we have to shift the focus quite a bit from developers towards our customers, our real users. Sometimes developers are your users, but if your customers are in a different domain, you have to know the domain you're working in. So shifting the focus might sound great, but it's not that easy to actually do. And if you're asking how to actually properly do it, when end-to-end tests come into place, it's important to appreciate the idea of user-centric testing, or you would call it end-to-end task testing. There are many names for that. So, with the user-centric testing, what you're trying to do, and what people have been doing wrong for a long time, is instead of focusing on interactions, you're trying to move towards tasks. Or in terms of very technical terms, in terms of at least Selenium, we would call it going away from page object model towards so-called screenplay pattern, where the abstractions you write have to focus on the operations your user interacts with. So to give you an example, imagine you're writing the authentication form, a login form, and the login form has a username, password, and the login button. So if you want to write the page object model for interaction-driven tests, you would have it very explicit. So your main audience for those tests will be testers themselves. So an example, you would be something like select element find by user field, send keys, username. So it would be very like cryptic for an end user, or people often, they say behavior-driven development is so great because you can show it to a business person, they would understand. I'm not saying that. I've never seen behavior-driven development real life that you share between like different stakeholders. But when it comes to these sort of tests, when it's very interaction-driven, there might begin this context shift for developers, the production developers looking at your tests. But when it comes to screenplay pattern or task-oriented test writing, you're trying to abstract it even more, where you just say login form dot accept username and password, login form, submit. Those abstractions really focusing on how would the customer interact with it, rather than having those complexity of send keys, find by element. Those abstractions all have to exist inside of the abstraction. Have explicitly shown to your developers or testers, so you have to do that properly. But going to the app, for the end-to-end testing, the common way to test anything these days, at least for the web, is obviously Selenium WebDriver. And don't get me wrong, Selenium WebDriver is awesome, because honestly, by now it's a de facto end-to-end tool. It's something we all get started with when we have a mobile web application, and sometimes even mobile, when we're trying to test responsive apps, which have been quite popular these days, because it really established testing standards for many of us. It's very generic. In other words, it can work for any sort of framework out there, UI framework. And it has so many integrations, whether it's an open source integration or an enterprise integration. So companies acknowledge the existence of this tool, and I believe I've seen so many job postings with the Selenium WebDriver being a requirement. And there is a reason for that. But Selenium WebDriver, architecture-wise, it's fairly simple. That being said, it took a while to write it and get it to the point where we are at right now. But honestly, it's basically you have a bindings to individual browsers, you have a Selenium driver, and you have a bindings to any language of your choosing. So you're not bound to any particular programming language. You can write it in anything you want. But this is where WebDriver.js come into play, because again, I've been trying to shift away from writing your tests on the language of, let's say, Java, for basically that people often use for writing the backend. Instead, I'm trying to highlight if your team is really oriented on writing client-side code with JavaScript, also have your testing team writing JavaScript. This is where Java.js, and it's very important, by the way, to have JS with S being small, because if you were to try to Google WebDriver.js, both capital, it's a different framework. So the indexing on Google hasn't been updated since that naming was changed. But ultimately, WebDriver.js, it's still under the same blanket of Selenium team. So it's under Selenium HQ. And so Selenium WebDriver.js is the same pattern of, it's still de facto end-to-end tool, still the same testing standards, it's still generic, and it has as many integrations as the Selenium WebDriver that you've encountered before for Java, C#, or whatever it is out there. So the Selenium WebDriver.js follows exactly the same principle of architecture, except the bindings, the language you have to use, would be Node.js. Again, if your team is writing code, the production team writes code in JavaScript, it might be a better choice. And the tests, again, are written the same exact way, arranging, acting, and inserting. You would have, again, as always, fairly verbose setting up the driver and killing the driver afterwards. Then you would have the actual test. You would access the URL of your choosing. You would find the values you want by class name. You would type a value in that element, and you would assert it the same way you would do it with the Selenium WebDriver. You find an element and you make sure it actually renders. So the thing I'm showing here is not how to write WebDriver.js, is that if you wanted to shift away from what you're currently doing, the learning curve is not steep whatsoever. Unfortunately, there are not just only good parts, there are complexities with Selenium WebDriver. In general, with the end-to-end tests, you basically have four main things you want to consider. It's how you find elements on the UI, the locator strategy, how to locate them, the test flows, how you even write those tests and how they execute it, and what kind of UI frameworks can you target. Is it generic, is it React specific or Vue specific? You want to know that. When it comes to WebDriver.js, it follows, if you approach them from those four principles. Selectors is very simple, the same as WebDriver.js, the same as Selenium WebDriver for Java or C#. It's by ID, CSS, by class name, by XPath. Locator strategy, good old by locators. Test flows, they used to have something called Promise Manager. Fortunately, not anymore. But the main point they were trying to make here while writing Node.js is to make, again, the learning curve as flat as possible. In other terms, they wanted to make it so you write your test top to bottom. You don't have to worry about this whole execution callback hell that some JavaScript developers have to encounter. You don't want to have your tests as complex or even more complex than your production code. That's one of the things you have to avoid. So they've tried to make it simpler. Before with Promise Manager, now they do it slightly differently, but you still can just write top to bottom tests with WebDriver.js as well. SPAP types wise, they are really writing tests, allowing you to write tests for generic UI framework. So any UI framework you have, you can write a WebDriver.js test for it. But it still looks limited. I mean, it's generic enough, but we don't write our UI framework applications in all sorts of frameworks. We usually stick to at least one at a time. And if you were to look for something better, something more specific, let's consider a different use case where you have an Angular app. And Angular, you probably all played with, it has like models, controllers, components. It's still one of those component-driven frameworks with a bunch of, the one thing I want to make sure that we're all familiar with is that they have a slightly different selectors to some extent. So they have like models, iterators, ng classes, and lists as well. So they have kind of a Angular specific selectors, locators. And it's important because if you're using WebDriver.js for that, you might have to write some hooks and wrappers around it. And that's not always the best choice that you have to make. Because one of the biggest things we face as writing an end-to-end test is the flakiness of our test. In other terms, when the test is failing and you can't determine easily why it failed. In other words, it's the whole idea, it works on my machine, or it doesn't work on the second time I run it, or as we call it, non-deterministic tests. And it's a very common problem. And with all those fancy single-page application frameworks, it even becomes more of an issue because you don't know when a certain component is loaded, so you don't know how to even test for that. This is where, in the case of Angular, as an example, we of course will test it first with unit tests and integration tests, but when it comes to end-to-end tests, we can do better than WebDriver.js. We can go beyond that. We can have Protractor. Protractor is one of the testing frameworks that was implemented by and supported by an Angular team itself, and it gave quite a support to the test automation teams. And the main reason for that is because now, because of the same team, the production team and the testing team, they're able to tell the test framework, I finish loading the app. I finish rendering my app. I finish loading the component. So it's easy to actually get going with the testing and finding the element. You don't have to wait for it to be loaded. You know it's loaded because the testing and the production code communicate with each other. So the Protractor, it's built on top of WebDriver.js. So everything WebDriver.js it has, and then some. It still uses Selenium server, and it has a state-aware component to it. So basically, it communicates with AngularJS applications that you're testing. Those four complexities that I mentioned, selectors, locators, test flows, and the spot types, when it applied to Protractor, selector-wise, they use element bindings. In other terms, those elements I've showed you, the models, the iterators, they still exist, but you can connect to them directly. The locator strategy-wise, you can connect to the individual models or repeaters or whatever you have in Angular using an specific API that Protractor team supplied you with. Test flow, it's again application state aware. In other words, you know in a Protractor that the Angular app finished loading, and it's all done by the team behind Angular and behind Protractor. And Spot wise, it's really Angular oriented because it knows about Angular. If I were to try to show how the test is written, the same way as all other tests of ranging, acting, and inserting. So here, I go to the URL, I find the model, but here you can see that I find it by .model. So it's those exact ng models that were highlighted in the Angular app itself. And the same way I can do the assertions of my choosing if I wanted to. The whole point here is that the Protractor, if you want to switch to that, if you're writing the Angular specific tests, you can easily do so. But Angular is great and so, but maybe for the better or for the worse, we have so many other UI frameworks out there. There is obviously React, Vue, there is the Ember, Backbone, and many other ones. I would never be able to mention all of them here, of course. But let's say I wanted to write and run my Protractor with React application. You can do that. You can easily do that by just simply turning off the synchronization. By synchronization, what we mean here is that we are aware of Angular communicating with the basically test would not start executing until the app is loaded. But if your app is not Angular, it will ultimately never get loaded, right? So with React, you can turn it off, and so your Protractor test will still run. But unfortunately, it doesn't really make much sense, because those connectors I've showed you before, by model, by controller, iterator, aren't going to be applicable here as much with React. So if you want to just go in further than that, people often look towards non-Selenium UI test frameworks these days. If you don't want to have a generic Selenium WebDriver JS, they look at something else. And these days, I mostly see two of them are highly popularized. One of them is still called TestCafe, and the second one is Cypress.io. That's been getting quite a bit of traction. So far, I've kind of mentioned a couple times, but there are so many patterns out there. Whenever you try to estimate or compare different frameworks, whether it's test frameworks or production frameworks, the same goes here. So for these UI non-Selenium test frameworks, we have common patterns where they have been trying to handle weights in a proper way, in a sense, with these frameworks being newer than Selenium or any other tool out there. They know of the main issue that we've all been struggling with, which is flakiness of tests. Basically, in other words, we don't know when the elements are loaded. So they've been trying to handle waits, or in other terms, waiting for the element to be loaded in the proper way. Because of the number of browsers and tests that we all work with, especially with Selenium or end-to-end tests in general being a regression suite, as a result, we have so many of those tests. Be able to execute them in parallel is a major consideration everyone who makes those test frameworks have to keep in mind. The rapid test development has been a major concern of those frameworks as well. In other words, they've been trying to give you a way to write your tests and execute them instantaneously. So have as little of the threshold or the wait time between writing and implementing and testing and running your tests. With so many manual testers out there, which is great, manual testing still has its place in the modern world of development. Still, that being said, I see that recorders kind of make comeback, where you basically have this plugin or IDE, some people call it, where you would click a button, or like you basically would go manually through the application. It records your operations and then saves it as a test script. So I see all these four very well represented in the TestCafe and the Cypress.io. So to look at them a little bit closer, I'm not going to go into them in too much details, but I will still highlight a couple of things I want to mention. So when it comes to the TestCafe, it handles waits fairly well, I would say. It really waits for the components to be loaded. It does it well with Vue, React somewhat. This whole new frameworks with this web components, like Lightning Web Components, I don't see it doing it that well, because each component is almost like an application of itself. That being said, for Vue, it's doing a good job, I would say. Parallel execution, TestCafe is also very good with that. You can execute lots of tests in parallel in potentially different browsers. The rapid test development, similar to the Cypress.io, they have their own IDE, their own development environment that I'll show you in a second, and they also have a recorder that they're trying to give you an example of. But in terms of actually writing the code, this is the code from their official website. I like their website to some extent. They have a nice recordings of different use cases how to use the TestCafe, but Cypress.io is much better in terms of documentation. It's actually one of the best documentation I've seen out there, technical wise. So, but with TestCafe, the tests you write are they very embrace this idea of a test flow, a kind of a promise pattern, where you have this whole stream of functions, where the way it's done, if I were to write a test, I don't do this multi-line wait for a single element, then do this, then do that. Instead, when first operation is completed, it goes to the second, to the third, to the fourth, same way as promises would work in JavaScript, where in this scenario, my test case starts by typing the text. If that's completed, I press a button, I click on a button. If that's completed, I go to the assertion step. It's all one line ultimately, even though I position it to be in a new next line for every statement. But here, this is how they've been trying to embrace this idea of a wait for a kind of a promise style, like avoiding callback hell in this particular test scenario. But again, they also really work for recorders and the IDEs. They have some enterprise support, so they're not like just open source, even though they are, but some of the recording functionalities might be an enterprise level. The recorder-wise, they're very good. Again, it's more of a drag and drop kind of a IDE that you can exercise. So, but the most important thing is if you have a team that's primarily manual testers, it's something they can play with, especially because you can export this scenario as their actual code and maybe utilize elsewhere and potentially rewrite. I've worked with Selenium IDE before in the past, like Selenium 1. As you know, Selenium is also remaking its IDE. Going to be Selenium 3 you call it, or some 4, I don't know. But Selenium IDE also has been quite popularized as well. Hence, the TestCafe is also building its own recorder and the UI. It's also an open source product. You can take a look at it as well. But the one that I really like the most is the Cypress.io in terms of non-Selenium frameworks. And again, it follows the same patterns. They handle weights pretty good. Parallel execution, unfortunately, Cypress.io currently only supports Chrome. It does not support other browsers. As a result, it's been one of the issues, so you can't really run parallel browsers at the same time. And it's been one of the main blockers for enterprise companies implementing it when, for some of the customers, it really matters what kind of browsers they use. If you ever work with the customers in some parts of the world, the one part of the world I know of still uses Internet Explorer 9. So if you were to run the test for that, Cypress won't be able to help you. But you know, if you're a startup or you're really setting the blocks for customers to use the latest and greatest browsers, Cypress.io might be a good choice for you as well. Hopefully eventually they'll be able to support more browsers. Still, it's a complexity for them for sure to tackle that. They have a very nice rapid test development infrastructure, and I'll show it to you in a second. And they also support record and play functionality too. Example-wise, code looks almost the same as you would do on a Selenium JavaScript, Selenium WebDriver JS. But here, what I like about it, of course, you have these simple operations of having the user field, the password. They can also fetch it from like hidden configuration, so you don't have to actually write your passwords in the tests themselves. So that's quite a nice processing for that. What I like also about it, some people struggle with the UI tests to be able to control things like cookies. Cypress does it pretty well as well. In terms of the API, they did a good job. And again, they have a great documentation. I really like the docs and also the videos that they supply. And they've been giving more and more talks these days. But when it comes to the IDE, that thing I actually appreciate the most. Because it's live reloading tests. As you write them, you can see how it's applied. You can easily do the debugging by just having like a pause operation, so it will actually stop there. It's similar to the debug point you would have in your IDE of your choice, or if you just put a debugger statement in actual JavaScript. But here you can actually stop the test itself if you're not running them. Like if you're used to running your test in using Java in IntelliJ and you put like breakpoint, you can do a similar thing here by just writing this pause statement. And they have many other use cases which well described in their website. And I really like the UI that they have here. But the most important thing with everything I've said so far is that finding the right tool for the right platform, for the right problem that you face. And with so many test frameworks out there that I haven't even mentioned, there is a WebDriver IO, which is quite nice though, if you still want to stick to the WebDriver. NetWatch.js is fairly old, but still out there. WD, and there is also Nemo, many abandoned projects as well. But one of the most important things you have to avoid is the tool mix-ups. When you have different tools in place used by your testing team, now you have this whole problem with increased complexity, because now you have to have a new hire or basically or an intern of some sort. You would basically have to teach them multiple tools. It's a complexity you would have to have in a team. You're going away from this domain-driven design approaches that I've said, basically this idea of common language, of ubiquitous language. You're going away from that because now, even within the same team, you can't communicate the same language with so many different frameworks in place. You want to unify that. If you wanted to choose what framework to use, you really have to. Some people look at the GitHub stars. I don't know how useful that is. That's still useful for sure, and also just looking at the dates of when was the last pull request, if people still working on the issues. I've been recently very upset with one of the frameworks I've been using for like screenshot testing for Android because the team just abandoned it. So it's important to look at how proactive or reactive the maintainers are. People often actually look at the npm package downloads, how popular it is, how often it's downloaded, because you know if they have a huge user base, you can bet it will be actually maintained if someone encounters an issue. It's how many external integrations there are. In other words, do enterprise companies or open source communities accept this framework, build like integration or extensions for that? And always have a proof of concept when you try a new tool. Don't just, we're moving to Protractor for no reason. Give it a try, show it to your team, discuss. Don't just make a executive decision. Show it, exercise it, try it. But more importantly, there are two main points: is how flexible the framework is and what's your particular use case is. When it comes to flexibility, what's important is the cost of transition. Does it even make sense to transition to this whole JavaScript thing that I've been talking about? Maybe it's actually fine to stick to Java. Maybe that's true. What's the return on investment to even rewrite your existing infrastructure? That's also valid. But if your development team, is writing JavaScript alone, maybe a good choice is to leave your existing test in Java and now try to write it in JavaScript for the newer product. So basically leave the legacy system alone, and for the newer product, try out the whole JavaScript. And if you see a major benefit, maybe you'll come back and rewrite the Java as well, but that's unlikely. When you're choosing the framework, really think about ability to customize. If your team is today committed to Angular, and you say, now we have to switch to Protractor, but apparently in the works, your team is thinking of moving to something better, something newer, like React or Vue, or another 1,000 of frameworks that will come out by the end of this conference. You have to make sure you discuss it with your team and you're able to make a change, because if you commit to Protractor, your test might be not as customizable to a new framework that you will shift to. And be able to replace the frameworks is also important. You don't want to commit to it like in those old days of HP hardware, where if you buy it, you have to always stick to that company. You don't want to have that. You want to have a flexibility. And more importantly is your individual use case. You can't just use something that works for some other team. Here you have to think of your team expertise. Does your testing team know JavaScript? Do they even want to try it? Are they ready for that? What kind of application your team uses? Like what kind of framework they use? Production team. If they don't do JavaScript whatsoever, maybe it doesn't even make sense to discuss that. And can your test infrastructure even handle that? If they can't, maybe look at other solutions or other services outside of your company, like Sauce Labs, Browser Stack, which basically allow you to run your tests outside of your premise. But more importantly, just overall this talk, I have just a couple of call for actions for you. Basically, really evaluate your test architecture. Think of, maybe it even doesn't make sense to make any sort of shift. Maybe you're already happy with whatever you have. Maybe you're happy with the reverse pyramid, or maybe you already have an ideal test pyramid in place. Then no changes are required. Think about that. Know your domain though. Know what customers you have. If your customers are developers alone, if you're API first team, then never write WebDriver tests. Or if your UI is driven by API calls primarily, don't even write WebDriver tests. Don't even write end-to-end tests. Just stick to API tests. Use like REST Assure for REST test or any other sort of API test frameworks like Postman or something. Don't go to the end-to-end right off the bat. Switch your focus so you actually have a regression suite that works and can be run by your team and people don't get depressed every time they have to run it. And the unify test strategy, don't have those tool mix-ups. Have this discussion between your developers and testers. If anything, try to merge the gap between the two teams, the two parts of one software product. But last but not least, really experiment. There are so many new frameworks, so many cool tools. It's always worth trying it out and seeing what works for your team. But with that, I really thank you for your time, and we'll go to Q&A. But first, thank you. All right, let's go to this. What are your thoughts on code coverage? Oh my God, don't get me started on that. My main pet peeve is the code coverage in general. Sometimes, more often than not, when people establish we have to hit a number for the sake of a number, it's people's way, especially managerial way, to try to control you and have some metrics behind it. When it's just a number for the sake of a number, hate that with all my heart. But when it's you're trying to establish, actually I like the approach, you test what you think would be the most complex part of your application. If you're a financial institution of some sort, then hell yeah, exercise this part of testing this API as much as you can. Have like almost 100% coverage if you want to, but don't go to craziest either. Don't have this 100% just for the sake of it. So code coverage, good idea behind it, but can be used in a bad way if it's really about the control. Can you combine Cypress with BDD Cucumber? Yes, you can. Cypress IO has been getting so many integrations. So many enterprise companies have used that and implemented solutions for that. So Cypress.io has been growing like crazy lately, and I've been speaking at many conferences on that. Would you recommend Cypress IO or TestCafe for Angular-based application because Protractor control flow seems to have problems when you use WebSockets? Yeah, I've heard that complaint about Protractor. I would say Cypress.io makes sense to try. It's cool, but don't try it because it's cool. Again, consider your use case. Do you care about newer browsers? One of the issues I've heard with Cypress.io, don't quote me on that, but I talked to some of they might face issues in the future with how the Cypress.io works, because they might have to use like a plugin in the future to use to support other browsers. So if your other browsers are important for your team, it might be a problem. If Chrome, you don't care if it's like how it works on IE as much or Internet Explorer, then Chromium and Cypress.io I think is good to try. I hear great things about usability and developer experience for Cypress.io. And again, as I've said, documentation is so good that learning curve is quite flat. And I mean, it's always good to try something new. If anything, it will improve your testing practices because you will understand how it works. But give it a try first. Doesn't work for you, switch back. What do you think about mixing end-to-end UI test with REST API testing like REST Assure? Oh, I love it. I haven't written a WebDriver test in so long, meaning like half a year maybe, and I'm so excited about that. There's nothing more pleasurable of not writing WebDriver tests that much, because honestly, you can write like one WebDriver test, and everything else, it's all driven by API more often than not. You can just write those API tests first and leave it at that. Because people write UI tests for every single edge case out there, and nobody will run it ever, except it's going to be a regression suite. And one thing I like to do is basically purge, like a movie, where basically I go and see if the tests haven't failed like in a year, delete those things. Don't have a 10,000 tests running and just using your resources. And if you see that you deleted so many UI tests, just do API testing alone and do very few, maybe 10, I don't know, UI tests. So I'm really for that. I love API testing, and UI testing is not that great. Yeah, but thank you though for questions. Great questions though. Thank you so much.